Welcome to Zeolite group of minerals. So the outline of the topic, it includes introduction, general characters, physical properties, optical properties, its structure, chemical composition, zeolite group of minerals, analcime like analcime, natrolite, chabazite, heulandite, stilbite, and application of zeolites. This is the outline of the topic. And coming to the introduction, so zeolites are tectosilicates, that is the silicon oxygen ratio is 1:2, and they froth or boil up on heating. Suppose when we heat the zeolites, they will froth or boil up. And zeolites is as the name, it has come from a Latin word that zein to boil, and lithos means stones, and it has a special properties like cation exchange capacity. Suppose if we take so the cation like calcium, it can uh, be exchanged by sodium ions, and in industry minerals possessing this cation exchange capacity, they have great application. And all the zeolites, they possess zeolitic water, and this water, it can be expelled from the minerals even without disturbing its structure and composition. So in minerals, suppose if you take mica, amphibole, etc., we can see the structural water. The pores which are there in the chemical structure are known to contain water, and they contain certain cations also. So it can be noted that the overall the composition of zeolites is similar to most of the clay minerals. For example, both the mineral clay and zeolite, they are known to be of the same composition like alumino-silicate compounds. However, it is important to note that zeolites do not have the same crystal structure as in the clays. So if you take the mineral clays, they have a layered crystal structure which has the ability to swell. Suppose when they absorb water, they are swelled. That means when water is absorbed, they have the ability to swell and shrink also. That means when water is removed, they shrink. So zeolites can exchange other positively charged ions for the metal ions which are originally there inside them. So these are also known as a cation exchange capacity, and they can gain or lose their water molecules very easily too. So this is the called reversible dehydration. And hydrated aluminosilicates of sodium, potassium, and calcium with other alkali and alkali earths such as barium and strontium are also present, and typically occur in amygdales and cavities in basic volcanic rocks, and also in other late stage pegmatitic environments. And the general formula of the zeolites is Na2K2 CaBa, that is calcium and barium, along with the aluminium, silicon oxide, and number of molecules of hydrogen. So coming to the general characters, the zeolites possess low hardness and low specific gravity and low refractive index. All these are low hardness, low specific gravity, and low refractive indices. The hardness, it varies from 3.5 to 5.5, and overall the specific gravities of all the zeolite minerals, it varies from 2.5 to 2.8, and they are all hydrous aluminosilicates of calcium, sodium, potassium, and rarely barium and strontium. So in most of the other properties, they are very similar to the feldspars. So they result from the alteration of the feldspars and other aluminous minerals of igneous rocks. Coming to the structure of the zeolite, the zeolites belong to tectosilicates. In tectosilicates, all the tetrahedra share all the corners with the neighboring tetrahedra and form a three-dimensional framework, and that's why these are also known as a framework silicates. So here the overall the structure, the resulting composition is SiO2. So the excellent example, we can say that the zeolites, and apart from the zeolites, quartz and feldspars also, they belong to tectosilicates. Zeolite group of minerals, with the possible exception of analcite and all the zeolites, they occur as a secondary minerals, filling up the basalts and lava flows, etc. And they crystallize in almost all the crystal systems. Even though there are about 40 minerals under this group, only 5 minerals are very common, and we are discussing that. So these 5 minerals are like analcime, natrolite, chabazite, heulandite, and stilbite. Analcite, it has sodium, aluminum, silica along with the water molecules. So this belongs to cubic system. And natrolite, that is a sodium aluminosilicate along with the 2 molecules of water molecules, and it belongs to orthorhombic crystal system. And Chabazite, this is calcium, sodium, aluminosilicate with 6 water molecules, and it belongs to hexagonal rhombohedral system. And Heulandite, this also have a calcium aluminosilicate along with 12 water molecules, and it belongs to monoclinic crystal system. And Stilbite, it has a sodium, calcium, aluminosilicate along with 6 water molecules, and it belongs to monoclinic crystal system. Coming to the properties of zeolites, these are very important, and zeolites are all alumino-silicate minerals with a three-dimensional framework structure, and they are characterized by the properties like porosity, cation exchange, adsorptions, exchange capacity, like that. So porosity means zeolites possess porous structure with regularly sized channels and cavities, and these pores are able to accommodate various cations, water molecules, and other substances. So the cation exchange property of the zeolites, they have a high affinity for cations, which are positively charged ions, and they can exchange these cations with other ions in the surroundings. So this property makes them valuable for ion exchange applications. And they have another important property like adsorption, and zeolites have a strong adsorption capacity for gases, liquids, and even certain organic molecules, and they can selectively trap and release specific substances, which make them useful in separation processes. Coming to the other properties, like they have molecular sieve effect, framework structure, crystallinity, and all these things. Molecular sieve effect means zeolites, they act as a molecular sieve. That means they clear they have the ability to absorb only certain molecules. They allow only the molecules of a certain size and shape to pass through their pores, and this is very important. This sieve effect, molecular sieve effect, is very important for separation and purification processes as well. And they have the framework structures. They have an interconnected framework of these tetrahedral units forming a three-dimensional lattice, and this lattice structure, it results in a network of channels and cavities within the crystal. And coming to the crystallinity property, so zeolites exhibit high crystallinity, which means that their atoms are very well organized and well ordered and repeating pattern. And this crystalline structure is responsible for zeolites' stability and also the consistency in other properties. So coming to the various zeolite group of minerals, so Analcime, Natrolite, Chabazite, Heulandite, and Stilbite, all these properties are have to be discussed. So Analcime, coming to the Analcime, it has a chemical composition of sodium aluminosilicate. So minor amounts of potassium and calcium, they substitute for sodium, and a silver bearing synthetic variety also exists, that is known as Ag analcite or silver analcite. So analcite is usually classified as a zeolite mineral, but structurally and chemically it is more similar to feldspathoids. Analcime is not classified as an isometric crystal, as although the crystal structure appears to be isometric, it is usually off only a fraction of a by a fraction of an angle. Coming to the physical properties of Analcime, so it belongs to cubic crystal system, and form and habit, it exhibits in the form of trapezohedron is common form, and also massive and granular. And the color, it shows milk white, colorless, but occasionally grayish, greenish, and pink also. So cleavage is cubic, that is along the 100, and fracture, it has subconchoidal and uneven. It has a vitreous luster, and the transparent diaphanity is about very transparent mineral, sometimes maybe opaque also. So it is transparent to opaque, and tenacity is brittle, and specific gravity is about 2.24 to 2.29, and so trapezohedron form and subconchoidal fracture are the important diagnostic features. Coming to the optical properties of analcime, its color is colorless, and it has a habit of anhedral crystals in infilling interstices, and it has a poor cubic cleavage, and relief is moderate, and refractive index is below 1.54. Coming to the occurrence, analcime is a primary mineral in some alkaline basic igneous rocks, and it occurs also as a late stage hydrothermal mineral crystallizing in vesicles, and occurs with the zeolites like thompsonite and stilbite. As an athigenic mineral in sandstones, which are associated with the zeolites like heulandite and lamonite also. Coming to the natrolite, so it is a sodium aluminosilicate along with two water molecules. This natrolite is a tektosilicate mineral. It belongs to the zeolite group, and it's a hydrated sodium and aluminosilicate. And it takes its name from the Greek word that is known as a natrium. So natrium means soda. It means a soda with a reference to the sodium content of this mineral. And it can be occurs in different colors like pale pink, sometimes colorless, white, red, grey, yellow, or green. Some specimens, they have the capacity of fluorescence, orange to yellow under ultraviolet light. So the physical properties of natrolite, so it belongs to orthorhombic crystal system. Sometimes it is exhibits pseudo-tetragonal habit, and form and habit, they usually occurs as acicular or fibrous radiating crystals, as you have seen in the diagram, and rarely prismatic, sometimes also granular, compact, or massive. Color, it occurs in white, rarely yellowish or reddish colors, and the cleavage, it is perfect 110 cleavage, and fracture, it is subconchoidal to uneven, and luster, it is vitreous, sometimes pearly also. Transparent to translucent, its diaphanity is, and hardness, it is about 5, and specific gravity 2.2 to 2.6, and it is in association with calcite, nepheline, sodalite, quartz, and other zeolite minerals. So diagnostic features are acicular or fibrous radiating crystal, and it exhibits a subconchoidal fracture. Coming to the optical properties of natrolite, so the color is colorless, and habit, generally it occurs usually as anhedral crystals filling interstices, and it has a poor cubic cleavage. It has a vitreous to pearly luster, and it is biaxial positive, and the 2V of natrolite is about 58 to 64 degrees, and the relief is moderate, and it alters to serpentine. Coming to the occurrence and uses, natrolite is a common mineral in vesicles, amygdales, and other cavities, and also basic extrusive rocks which are being deposited by hydrothermal solutions. And it also occurs in altered cyanides, uplites, and dolerites as well. And it occurs along with the Analcime, Stilbite, Heulandite, these are the other zeolite group of minerals, Chabazite and Lamonite. So natrolite, it may form from the alteration of either feldspars or feldspathites minerals. And these specimens are often associated with the quartz, Heulandite, or apophyllite, and other zeolites. Transparent natrolite crystals, they are occasionally placed on rare gemstones for collectors. They may be used in gemstone industry. And as a zeolite, natrolite is also used as water purifiers and chemical filters. Coming to the Heulandite. So the Heulandite, its chemical composition is calcium alumino-silicate along with 12 water molecules of water. So it has a crystal system monoclinic, and so this crystallizes as a translucent, and its tenacity is brittle, and sometimes it exhibits coffin shaped crystals in a range of different colors like white, red, gray, and brown colors. The molecular structure of the Heulandite, it is an open framework. So these are all Tekto. They are made up of 6-membered rings of silicate tetrahedra which are connected with parallel planes, and which consists of 4 oxygen atoms which are arranged in a triangular pyramid around the central silicon atom, and they have the cation exchange capabilities, and these are helpful in water softeners. Coming to the detailed physical properties, it belongs to the monoclinic crystal system, and the form and habit or tabular crystals are very common, and sometimes it may be granular as well. And color, it exhibits different colors like white, brick red, and brown, and the streak is white. It has a perfect clinopinacoidal cleavage, and fracture is about subconchoidal and uneven, and it has a vitreous to pearly luster, and diaphanity is about transparent to translucent, and hardness 3.5 to 4, and specific gravity very low, that is 2.2, and it occurs in association with other zeolites, sodalite, and quartz. Coming to the optical properties of Heulandite, so it shows colorless. It is colorless in thin sections, and habit, it's usually anhedral crystals filling interstices, and rhombic prisms or coffin shaped tabular crystals, and these are also granular massive. They are often in curved aggregates, and the cleavage is perfect 010, and it has moderate relief, and the optic sign is biaxial positive, and 2V is about 10 degrees to 48 degrees, and refractive index, it is below 1.54. So Heulandite is the most characteristic mineral of the cavities in basalts and other volcanic rocks associated with the Stilbite and Chabazite. It forms by the devitrification of volcanic glass and alteration of tuffs, and which occur in bentonitic clays. So it also occurs in cavities in metamorphic rocks, and as an orthogenic mineral in detrital sediments. Coming to the Chabazite, so the name Chabazite, it has come from the Greek Chabagios, so it is an ancient name of a stone, and Chabazite, a commonly hydrated sodium and calcium aluminosilicate mineral. It belongs to the zeolite family, and it is represented, its formula is represented as calcium aluminosilicate along with the 6 molecules of water. So within the crystals, the atoms of silicon, aluminum, and oxygen, these are linked in a 3-dimensional network rather than the chains or sheets. They are arranged in a 3-dimensional network which are traversed by open channels. These are occupied by the sodium, calcium, and other molecules of water. So it's very brittle, its tenacity is brittle, and it's glassy white or flesh red in color, and it exhibits in rhombohedral crystals which are frequently found in cavities in basalts or andesite, and it has important very important capacity as the case of the other zeolites. It has cation exchange properties. This is important in water softeners. Coming to the physical properties in detail, so crystal system trigonal, and it exhibits rhombohedra with the simple penetration twins common, and also it occurs as a massive form. And colors, it exhibits in different colors like white, yellowish or reddish, and its streak is white. And cleavage, it is good on 1011, and rhombohedral cleavage is present, and fracture is uneven, and luster is vitreous. Diaphanity is about transparent to translucent, and hardness is 4.5, and specific gravity 2.1. The association, it associates with calcite, nepheline, sodalite and quartz. Coming to the optical properties, color, it's white, yellow, pink, red and colorless. Sometimes in thin sections it is colorless, and streak is white, and luster vitreous. It belongs to biaxial positive, and this commonly shows brilliant paneling in 6 directions, and 2V is about 0 to 32 degrees, and it has a poor cubic cleavage. Suppose if this Chabazite, it can be identified in the field by its color variations such as white, pink, red, yellow and orange, and this mineral has a vitreous luster with a white streak. So varieties of Chabazite, Phacolite is a colorless variety, so it occurs in lenticular crystals due to its twinning. And this Chabazite, it occurs as a common mineral in cavities like basaltic or basic volcanic rocks with Stilbite and other zeolites and calcite. And it appears in the zeolite facies of some metamorphosed carbonate rocks with albite and epidote, etc. And this is very rare in limestone sunches, and hydrothermally deposited in cavities and joints or in ore veins. And it is associated with other zeolites, nepheline, melilite, olivine, pyroxenes, amphiboles, axinite, epidote, calcite, tridymite and dolomite. Coming to the stilbite. So stilbite, it gets its name from a Greek word that means to glitter because of the mineral's pearly sheen. And this stilbite is a member of the zeolite group. It's typically characterized by its white, peach, pink, yellow or brown in color. It has a wide variety of colors. Based on the amount of the calcium and sodium, again this stilbite can be further recognized. And this stilbite is not often faceted, but when it does occur, then the beautiful crystals make it very desirable for the mineral specimen. It looks very beautiful. Coming to the physical properties of stilbite, it belongs to the monoclinic crystal system, and form and habit, the crystals are platy on 010 direction, and they are arranged as sheaf-like radiating aggregates. And then usually it's white in color, and occasionally yellow, red or brown colors are also seen. And streak is white, and the cleavage is perfect 010 and poor on 100 direction, and it has uneven fracture, and luster is about vitreous and sometimes pearly on the cleavage faces. And its diaphanity is about it's very transparent to translucent, and hardness, it varies from 2.5 to 4, and specific gravity, it ranges from 2.1 to 2.2, and it is in association with other zeolites and also prehnite, calcite and quartz. So coming to the optical properties of stilbite, so it is colorless and non-pleochroic in thin sections, and habit, it usually anhedral crystals in filling interstices, and it has a poor cubic cleavage, and dispersion is weak, and it's biaxial negative, and it exhibits 76 degrees to 78 degrees. The 2V angle of stilbite is 76 to 78 degrees, and the relief is moderate. Of stilbite. Coming to the application of the zeolite, zeolites overall they are widely used as an indicator minerals in thick lava piles such as ocean floor basalts to determine the temperature and depth of the burial. So at what depth they are formed, and also to determine the temperature. So that's why they are widely used as an indicator mineral. And zeolites, they have the affinity for cations, that especially for positively charged ions, and they can exchange these cations with others in their surroundings. And due to this property, they are very valuable for use application as ion exchange applications. And this cation exchange properties is an important in water softeners. And another important property like molecular sieve effect property. So this is essential for the separation and purification, water purification processes. And due to its absorption capacity, zeolites have a strong absorption capacity for gases, liquids and even certain organic molecules. And they can selectively trap and release particular toxic substance, specific substances, making them useful in separation processes. So overall, we can say that the main uses of the zeolites in industry is catalysis, gas separation, and ion exchange. The zeolites are extremely useful as a catalyst for several important reactions involving organic molecules, and the most important are cracking, isomerization, and hydrocarbon synthesis. And zeolites is known to enhance healing and is helpful in absorbing and removing toxins. Raw stones in their natural state, they support strong and pure energy. So they give some energy, positive vibes. So they are used to enhance healing options. So, and Thomsonites, these are one of the rarer zeolite minerals. They have been collected as gemstones. These are the references. Hope you have learned some important facts about zeolites, and see you in the next video. You can subscribe to Explore Geosciences. Thank you for your time.